Something like that. Hopefully you can see that. I'm pointing my camera in the right direction. So we're going to start the stirrer. Probably want a setting of about 450. That's usually a pretty good setting. I may have to turn it up a little bit to get the stir bar started, because it's relatively viscous. I may actually even have to lower this a little bit to get the magnetic stir bar closer to the magnet. Sometimes it takes a little bit of tweaking to get it to stir nicely. Just lower these two clamps, lower that in there a little bit. So now you can see there's a nice vortex in there. We've got a good stirrer at a setting of about 450. That tends to be a good stir rate for this particular type of stir bar. And then we're going to heat this to reflux at about 57 degrees. So I'm going to turn my heater up here temporarily to about 150 just to get it hot quickly. And I'm going to grab a thermometer. 100-degree thermometer is good enough, which are the red alcohol ones. Right, this goes from 0 to 100, 110. And actually a good way to get the thermometer in there is simply to insert it down through next to the clamps. And you'll see we're at 20 right now, but that temperature should rise fairly quickly since I have this set at the 150 setting. I want to start my timer for my 45 minutes once it starts refluxing. And what reflux means is it's going to boil down here and condense when it hits the inner jacket that's surrounded by this cold water from the faucet. So we're going to turn that back on so we actually have cold water flowing at a reasonable flow rate, not too fast. And then it'll condense and drip back in. So we'll see it dripping off the tip of the condenser. And we'll also see what's called a little reflux line here, which you may or may not be able to see with my camera once it starts, where you can see it condensing. It'll look a little bit like a oil and water kind of sheen on the inside. We'll see if that's actually going to be visible. So far, we're in pretty good shape. So while we're waiting on that to get up to temperature, we can set up the rotary evaporator, which we'll need later to remove the methyl turbidal ether solvent after we do the filtration. And the rotary evaporator is sitting over here. It consists of a water bath, the instrument itself, the Buki Rotovap R114, which is basically just a motor that spins this attachment when the flask's attached to it, and then a condenser coil and a receiving flask. We're going to run ice cold water through the condenser coil from this bucket, and we have an aquarium pump in here that's going to constantly recirculate the water through that receiving coil so that the solvent, once it's evaporated, can condense readily. And then we're going to apply a vacuum from this bucket here. This is an aspirator pump. Basically what you're looking at here is two nozzles. We're going to pump water through those nozzles really quickly, and as the water goes past this side nozzle, the air is going to be kind of sucked with it as it goes through. So there's an inlet port here. We'll suck the water out here and blow it quickly through these two, and thus achieve a vacuum. The best vacuum we can achieve with a vacuum aspirator pump like this based on water is the vapor pressure of the water at whatever temperature it is in the bucket. So we're going to ice this down to 0 degrees so that we have the vapor pressure of water at 0 degrees instead of the vapor pressure of water at room temperature. And that's going to allow us to get a vacuum of about 17 millimeters of mercury. So I'm going to put this knob back in there. The first thing I want to do is I want to fill the bucket so that the level of the water is over the exit of the nozzles. That way it'll avoid splashing. And then the other thing it will do is when I put the ice in there, it will avoid the ice getting trapped underneath the inlet at the bottom which sometimes clogs it, causes it not to pull the vacuum we need. Generally, when you come, if you're the first person to use a Rotovap like this bucket will be empty because the solvent that we're removing does get mixed with the water. And if you saturate this water with a hydrocarbon solvent, the rubber gaskets in there will start to swell, and that's a problem. And generally, when you first come here, the water level in this other bucket should be at roughly the top of the aquarium pump. We don't want this all the way dry because sometimes it's difficult to get the water flowing again, but we run it most of the way down so it's ready for ice when the next person comes to use it. We have 3 of these rotary evaporators. The water bath is about $600, the Rotovap itself is about $2,500, and the vacuum aspirator pump is probably another $1,000. One of these Rotovaps has been here since 1994 that I purchased with my startup money when I first took a faculty position here. The other thing we're going to do is we're going to fill this water bath until it's about 1 inch from the top of the bucket. That'll be about the right depth for submerging our flask when it's ready. Basically what you're looking at here is a very high-tech moonshine still. The spinning of the flasks increases the surface area of the liquid in the flask so that you get a more rapid evaporation, and it also mixes it so that you don't get a local hot spot, which could cause what's called bumping, where you suddenly get a lot of vaporized solvent all right in one place, and it causes the entire thing to kind of shoot up. You may have witnessed that if you put like a cream of wheat powder or something into a almost boiling water flask. It'll suddenly all boil at once and come squirting out all over you. And then the cold water, the ice water through the coils, and the ice water in the aspirator allow us to get a much lower pressure, which decreases the boiling point and causes the solvent to come off quickly. So I'm going to plug in the Rotovap and turn on the power strip. And you'll see when I turn on the power strip that the water immediately starts flowing through the aquarium pump, so I'm running water through there now. And I'm going to turn this water bath on and up to a setting of about 35 on the dial so that we heat the water bath just a little bit. Really isn't necessary for methyl tert-butyl ether to heat the water bath, but I'm going to heat it anyway. So let's see if this is boiling yet. We're up at 40 something, so it's not boiling yet. And we can go over and get some ice while we wait. So I'm going to go ahead and fill up this ice bucket nice. It takes a fair bit of ice to cool down the water in both those buckets. We will put some ice in the aspirator pump bucket. Try not to spill too much. Kind of fail at not spilling too much. And it'll automatically overflow through here if I put too much in. So that should be nicely iced. Put that on there. And then I'm going to just put the remainder of the ice in this other bucket. It's not necessary that this flask be submerged in the ice. The purpose of the ice in this bucket is to make the coils inside there cold, not to make the flask itself cold. So we can put this bucket back. work to about 50. We need to rise about 10 more degrees before we will achieve a reflux. After this is boiled for 45 minutes, we're going to need to filter it. So I'm going to grab the funnel. This is the funnel that's actually going to sit in this iron ring to allow me to filter it. And I can attach that so that it's ready when I need it. And we're going to be filtering it into a 100 milliliter recovery flask. I want to use a recovery flask like this because it's much easier to scrape things out of a recovery flask as opposed to a round bottom flask where things can get stuck on the lip. So I'm going to sit that under the funnel, and I'll actually adjust that a little bit. So the funnel is just not quite touching the flask. That way there'll be enough airflow here that as I start filtering it, the air can escape as I filter. And then we're going to need to go and get some filter paper, which is not actually out in the lab right now, so I'll have to go to the stock room to get that in a minute here. So we're up at around 55 degrees, gradually rising. We may need to crank this up just a little bit more. We can't heat the solvent at higher than its boiling point because as soon as it starts boiling, we'll have an equilibrium of the liquid solvent and the vapor solvent, which gives us a constant boiling mixture. So we're sure that the temperature inside there is the boiling point of methyl terbutyl ether, which I believe is 57 degrees. And you can see it's starting to boil. Right? We've got a kind of a tan, what we would call a suspension. It's not dissolving, but it's suspended nicely in there. It's starting to boil, and I think you can see that it's dripping off the tip. Right? Occasionally there's a drip coming off the tip of the condenser. So we've got a good temperature. We're up close to 60. I'm going to want to monitor this a little bit before I walk away and do anything else, just to make sure it doesn't get too hot. I really don't want to heat the water bath more than about 70 degrees. For one thing, it'll start evaporating, and it's just not necessary. So we've got a good drip rate coming off there. We have definitely achieved reflux, so we can check our time. It's almost exactly 5 o'clock. So at 5:45, we'll be ready to cool this down and do our filtration. And now I can lower this a little bit. And you'll see that the little thermometer there turns on when it's heating and then off when it's not. And so I can turn it down until that light's no longer flashing, which means that it shouldn't heat too much more. We're at about 60 degrees. Which is a good temperature, just over the boiling point of the methyl terbutyl ether. We get a nice solid drip rate. And if you look in here, maybe you can and maybe you can't see, because I'm not sure what the camera is showing you. You can see that it's kind of right here. You can see it's kind of condensing a little bit. You've got what looks like a film that's kind of there and then not there. And you can see it expanding up a little bit here, right there at the edge. That's what we call the reflux line. We generally want to make sure that reflux line doesn't go more than about a third of the way up the condenser. At 60 degrees, it's probably going to stay right there in that lower section. So this is a good reflux. We're just going to let that sit there for about 45 minutes, right, to dissolve the sample. We've got our Rotovap set, ready to go. I'm not going to bother turning on the pump yet because we don't want to run it and let it warm up unnecessarily. And I'm just going to test that and make sure that it's about the right temperature by dipping my finger in. That seems about right. Alright, so that's boiling. Yep, seems to be solid at 60 degrees. that's all good. I'm going to go into the stockroom and grab some filter paper. We're going to be doing two different kinds of filtration. We're going to be doing a gravity filtration, just a coarse filter to filter out the part of the nutmeg powder that won't dissolve. And then we're also going to be doing a vacuum filtration once we get the purified material after we recrystallized it from acetone. So we need a fairly large piece of filter paper for the gravity filtration. Right. And we want a big piece. I don't want porosity fine though, because I want it to filter fairly quickly. I want the medium porosity P5 filter paper. I think this one will do nicely. So we're going to make a little fluted piece of filter paper here. We're going to fold it in half. We're going to fold it in quarters. And we're up at about 65. I'm going to lower that a little bit. And then I'm going to accordion fold it. Kind of make a little fan out of it. We've got our little fan shape. And then when I open that up, I'll be able to get a good surface area so that the filtration rate will be fairly rapid, and that'll sit nicely in that funnel. Poke that down a little bit. Generally I would have used a slightly larger piece of filter paper than this one. Not sure where that is, but I may go and try to find it while we're waiting for the reflux. So that's got the reflux set up. We're just going to sit here for 45 minutes and I'm going to